Okay, we have 4 rules today. These are all dealing with triangles. The first one that we're learning today is the Triangle Sum Theorem. You probably already know this rule. You might not know it by this name, but that's how we're going to refer to it. Triangle Sum Theorem. We're dealing with triangles today, so I'm going to start by just drawing a basic triangle. In any triangle, I could have drawn this triangle any way I wanted to. I want to make sure it's very clear that I'm not talking about a specific type of triangle here. So we've got A is an angle, B is an angle, and C is an angle. So you guys probably already know this. We're not talking about specific angle measures here, but if I look at all 3 of those angles, A, B, and C, do you guys know anything about those 3? They add up to a number. That's basically it, just a little bit more. What number do they add up to? 180. So triangles will always add up. The angles in triangles will always add up to 180 degrees. So that's what we've got here. Measure of angle A plus the measure of angle B plus the measure of angle C will equal 180 degrees. This is the one used more than any other out of these 4 we're learning today. So I'm going to go ahead and put a star beside this one. So there's kind of that main takeaway from each day. Linear pairs and vertical angles were probably the 2 most important from the first time we looked at angles. Alternate interior angles was the most important one from the ones we learned Thursday. So today I'd say triangle sum theorem is the main takeaway. So those 4 that I just mentioned will account for the vast majority of the angle rules that you need to use. Okay, we've got a relationship where these all add up to 180. What color do we use for that? Pink. So I'll go ahead and highlight that real quick in pink. All right, our description right here says, let's see, what does it say? It says the sum of the 3 angle measures in any triangle is 180 degrees. And I'm going to underline that right there. It says in any triangle. So don't draw a line to separate yet. I'm going to add a little bit more to this in a minute. Okay, what do you think our abbreviation is going to be for triangle sum theorem? You got it, TST. And honestly, this is one that students figure out pretty well. And we keep using this one a lot, so it gets to the point where I'll say, okay, what are we using here? And it's just people will shout out TST. So just understand TST, what we're referring to there. Okay, so I wanted to point out when this is useful. I want to give you kind of just a brief example of that, and then of course you'll get a lot more practice with it. So let's say you've got a triangle and you already know 2 angles. I'm going to say this is 50 degrees right here, and I'm going to say this is 64 degrees, and we don't know this angle right here. I'm going to call it X. So if you have a situation where you know 2 angles of the triangle, but you don't know the third, this is the classic example of when to use the triangle sum theorem. Because we know now that all 3 of these angles, 64 plus 50 plus X, will add up to 180. And there you go. You could also have situations where there's a triangle and they give you some expressions to use. So maybe it's going to be 2x right here, and then this is going to be 3x minus 11, and then this is going to be, let's go with 5x plus 8. So anyways, you know, we're not going to go through and solve this right now. We'll see examples like this. But if they give you 3 expressions inside your triangle, it's got to be the Triangle Sum Theorem, because now we can say 2x plus 3x minus 11 plus 5x plus 8 all adds up to 180. And there you go. We can figure out what x is going to equal from there. So I just want to make sure it's clear, like, what situation you're looking for in order to use this rule. We're going to do some problems in class today. Oh, you didn't need to write that. I'm sorry. If you did, well, okay, that's good. So this is the part that you needed to write. What I want you to write here is, if you know 2 angles in your triangle, or in a triangle, you can solve for the third. With TST. Okay. That's really the main takeaway. And I'll go ahead and move along to the next one. Huh? We have 4 total today. And the next one is called exterior angle of a triangle. This one will probably be new for you, but hopefully it's not. I don't think any of these are super challenging on their own. So I'll draw the diagram like so, a triangle. But this line extends over, and I'll label my angles like so. This will be angle A. No, I want that to be angle C. And this will be angle A, and this will be angle B. These rules today are interesting. They kind of go in order in how often we use them. So, Triangle Sum Theorem used, if there's triangles in the diagram, Triangle Sum Theorem is used almost every single time. Exterior angle of a triangle can be used quite frequently, more often than you'd expect. And then the next two just goes down in the prevalence, how often we see it. Okay, so we have to understand what an exterior angle is. Angle C right here is exterior. We kind of extended a line and then drew this angle connecting one side of our triangle to this extended line. So those are called exterior angles. We had exterior angles with our parallel lines as well, but this is a different kind of exterior. Interior is really straightforward. Inside the triangle is interior. So what we have in this situation is that those 2 angles, A and B, what do you think is going to happen? Add up and equal what? Add up and equal C. So the measure of angle A plus the measure of angle B will equal the measure of angle C. Alright, and our description is that the exterior angle of a triangle is equal to the sum of the equal to the sum of the two opposite interior angles. Is equal to the sum of the two opposite interior angles. So this is a 2 right here. All right, and our acronym for this one, if you've already gotten the description written down, what do you think our acronym is going to be? EAT, exterior angles of a triangle. EAT. Yeah, because this is, because this is kind of an oddball relationship, these two aren't showing equality. This one's actually going to be highlighted in blue. So I'll preface real quick by saying, don't write this down, but just a very simple example of an exterior angle of a triangle. I'll draw something here real quick. Again, don't write this down. So if I told you this was 131 degrees and this was 70 degrees, then you could solve for this angle, x, right here, with your exterior angles of a triangle rule. It'd be, well, x plus 70 are two opposite interior angles. Will equal 131. Yeah, there you go. X would equal 61 in this case. So this rule seems kind of obscure maybe, but it actually, like I was saying before, comes into play and can be helpful more often than you might think. And it's one of those that if you don't notice it, and we'll see some examples of this in class today, but if you don't notice it in the diagram, you can actually get by without it. Because notice in the same diagram that 131 and this angle right here, I'll draw it in red real quick. What is this angle relationship? Linear pair. So this is a linear pair. We can actually solve for that angle right there. And in this case, it would be 49 degrees. So if I solve for 49 degrees, well, I could add those two up with this, and that's Triangle Sum Theorem again. So I can get by without this rule, but the point is, this can save us a little bit of time and save us an extra calculation. So exterior angles of a triangle is a useful one to remember for that reason. Okay, let me erase all this and we'll write down our next rule. Okay, I will say the one thing to be careful about with exterior angles, you have to make sure that the exterior angle is set up the right way, where it's kind of an extended line coming out from the triangle and then it's connecting to one of the sides of the triangle. A lot of people will set this up whenever they see any angle outside the triangle, and they'll set it up the wrong way, but we'll just kind of see those in context later. All right, next one is called base angles of an isosceles triangle. And we need to remember what an isosceles triangle is. Can anyone remind us? Go ahead. I think she's going to give us the answer. She just has to.
Is it when all the sides are different?
Oh, isn't it when two are the same but one's different?
Okay. The key property is what Manuel just said, that two sides of the triangle have to be congruent, and then it's isosceles. Now, all three can be congruent, and it's still isosceles, but then we also call it what? If all three sides are equal, it's equilateral. An equilateral is an isosceles triangle. It's just more specifically equilateral. So I will draw an isosceles triangle here real quick. What do we call that? What do we call a triangle that has no sides that are congruent? I can tell you what it starts with if you want a hint. S. It does start with an S.
Scalene.
There it is. Scalene. Okay. Luckily, I don't know that the term scalene is going to come up too often in this class, surprisingly. So, isosceles and equilateral will. Okay. So, one thing that you might not have ever heard is that the non-congruent side of our isosceles triangle is called its base. So, the base angles would be these two angles at the very bottom. I'll go ahead and mark them real quick. I'll call this one angle A, and this one I will call angle B. And what do you think is going to be true about those two angles? They're going to be equal to each other. So the measure of angle A equals the measure of angle B. And when it's equal, we use yellow. I'll go ahead and start writing the description down. You can copy along with that. So base angles of an isosceles triangle are equal in measure. And we're going to add a little bit more to this. So again, don't just draw a line underneath this, but it's not much. So what do you think our abbreviation will be here? Bait. That's it. B-A-I-T. So now you have eat bait. Okay, now here's the main takeaway from this, and then we're going to look at some examples of this so that the full extent of what we could do here is really clear. So, if you see an isosceles triangle in your diagram, then you can be guaranteed that you will use this rule. But on the flip side, if there's no isosceles triangle in the diagram, you can completely forget about this. It's not going to come into play. So I'm just going to add that note. So it says, if you see an isosceles triangle, I'll just put ISO triangle in the diagram, then you will use bait. So I'm going to underline that. Of course, I don't have enough room here, but yeah, like I said, the flip side is also true. If it's not there, then don't even look to use base angles if there's not an isosceles triangle around. If you see an isosceles triangle in the diagram, then you will use base angles of an isosceles triangle. All right, this is stuff you don't need to write down, but I wanted to show you real quick. We have different ways we can use our base angles rule, and so I wanted to just show let's pretend that's isosceles, and there are some really easy examples of this. The first one being, if this is 68 degrees right here, and that's x, what is x going to be? It's going to be 68. It's going to be the same. You'll probably see stuff like this. It's really straightforward, really easy. You could also have this be your problem. If you know that 68 right there, what is this going to equal up at the top? Now, what do we have to do is really more the question. What's the process? Say that again. It all has to add up to 180. We already know what's that bottom right angle going to be. Okay, this is going to be 68. So now we have enough information. We can actually say that's 68 and that's 68. Well, we can set up a triangle sum theorem. I don't know that I need to go through the full process from there. But notice I was only given one angle, and I can still solve for that top angle. And last scenario to point out. Okay, let's say that you're given this diagram, and they tell you this is 42 degrees. All right, so if that's 42 degrees, and they ask you to solve for x, well, you can do that. And I'm not going to go through the full problem, but what do you think we have to do here? All right. Well, okay, so we know we have two angles here that are the same measure. You have x in the bottom left, you have x in the bottom right. So now we could set it up as x plus 42 equals 180. And then we can go through and solve for x at that point. So the main thing is if you have one angle in an isosceles triangle, you can solve for any of the other ones. That doesn't work for other triangles. It doesn't work for most other triangles. But, all right, let's look at our last rule. This is the one we use least often. And again, I'll kind of give you an example of when this one might come into play. This one is very straightforward, just called Equilateral Triangle. Okay, and I'm going to draw an equilateral triangle best I can on this page. There you go. That looks pretty good. All three sides are congruent. You've got three angles right here, A, B, and C. And what can we say about all three angles A, B, and C? They are equal to each other. So the measure of angle A will equal the measure of angle B, and that will also equal the measure of angle C. And we can go one step further. We know all these are going to be what angle measure? Well, they all add up to 180. So therefore, yeah, they will each be 60 degrees. That's just 180 divided by 3. So there you go, 60 degrees for angles A, B, and C. So our description here is that all angles in an equilateral triangle are equal in measure. And I'll also add, they're equal in measure, but I'll put in parentheses 60 degrees. Our abbreviation here is nothing super fancy. Just EQ and then the triangle symbol. Well, the problem with ET is that we already have EAT, so. Okay. You can find an empty seat. Okay, so let me show you real quick what the kind of example of using this one might look like. Because there's not a lot of times where it really matters that it's an equilateral triangle, but there might be a situation where you have a diagram where it says, all right, you've got an equilateral triangle right here. That's all well and good. But maybe these lines are extended down, and then you've got something like this. All right, so a weird looking diagram, but then you know that these three sides are all congruent. So maybe what you have to do here is start with that equilateral triangle and say, because it's equilateral, I know that this is 60 degrees. And then I can work from there to solve for, maybe you're trying to solve for this missing angle right here, x. So a lot of times the equilateral triangle is just part of a bigger diagram, and it's not something you need to solve on its own. But I mean, there are exceptions to that. So are there any questions on these four rules? Okay, now what we're going to do is we're going to spend a little bit of time just looking at a few of these practice problems.